Okay, first off, I want to start off by thanking everyone for taking the time to come see me speak. My name is Kevin Markwardt, and I work for Pythian. We are a global services provider for database support and DevOps and open source. And okay, this was working. Let's try that again. Nope. There we go. Got it working again. So we've been in business for over 20 years, and we commit to hiring the best talent around the world. We have people in India, South America, Europe, America, West Coast, East Coast, everywhere you can think of. And we don't just hire anybody. I've tried to send a couple of people over, and they got rejected because they just weren't technically up to par to the standards that we hold. Once again, we've been in business for over 20 years. We're 400 plus strong, and we have 350 plus clients. Some pretty big name clients as well. Not all of them are on here, only the ones that wanted their names put up. A little bit about me. I've been working in IT for over 20 years. I have 2 kids and 2 dogs and a beautiful wife. I've been with Pythian for 3 years, and I've been working with MySQL pretty much exclusively for the last 6 years. I am both AWS and GCP certified solutions architect. And I'm going to be going through Postgres today. Some people pronounce it PostgreSQL, some pronounce it Postgres. For this talk, I'm just going to be pronouncing it Postgres. Makes it a little easier not having to say QL every time afterwards. So I'm going to be going over the journey that I had in starting to learn Postgres. I've traditionally come back from a MySQL perspective, and that's what I'm going to be comparing a lot of things towards and trying to help inform you of some of the obstacles that I overcame in trying to understand how PostgreSQL was doing a lot of the same things that MySQL was doing, but they just do it in their own unique fashion. So I'm going to go over some major differences that I found, and then I'm going to go into some details on what makes Postgres special and why would someone choose PostgreSQL as their database platform. And so here's an overview of the major topics that I'm going to be going through. The command line clients, some of the client commands, and how they differ from one to the other, because that one especially was a big kind of culture shock for me. Database and schemas was another one. For some people that may be coming from a MySQL background that maybe don't know what a schema is, and because we don't have that concept within MySQL. Then I'll be going through user accounts and creations, the connections, and how the 2 different database platforms handle connections differently. It's pretty significant in the differences. MVCC and concurrency control, and how the 2 different database platforms do it their own way, but yet they're trying to accomplish the same end goal. And then memory management and replication. And finally, we'll look at the file system and how the different databases place the files on the file system and how they kind of structure them and stuff like that. First off, we're going to go over the command line. So with MySQL, if you're familiar with MySQL, these look very familiar. They have the base MySQL client. Then they have the MySQL admin, which gives you an administrative client to run different commands, such as shutting the server down, starting it up, MySQL dump for doing logical backups, and then Oracle provides a MySQL workbench for a graphical client to being able to interact with the database. Now from a Postgres perspective, they have very similar, but some differences. They have the pSQL client that you'll use to connect into the database. The way Postgres does it is a little bit different because when you typically install MySQL, you're a particular user or a root user, and you'll use that user to just log into the client using the username and password. But with Postgres, majority of the time, you're going to become that Postgres user account that's created when the database is installed. And then once you become that user, then you'll launch the pSQL client. I do it all in one command there to then become the user and then run the command to log into the pSQL command line client. And then they also have PGCTL, which is very similar to MySQL's administrative client to being able to start and stop the server and other administrative tasks. pgdump and pgdumpall are their logical backup clients. The pgdump is just for a specific database, where pgdumpall will dump everything, the databases, the schemas, the permissions, where you're not going to get a user dump or permission dump with pgdump. So if you want all of that stuff, you're going to want to use pgdumpall. Now, one thing I did find pretty interesting is for the binary backup. For MySQL, most of us have heard of Percona extra backup. That's typically how you're going to do a binary backup of a MySQL database. But Percona offers that within their software platform, PG-based backup, to be able to do that step. And then they also offer pgadmin as their graphical client to interact with the database. Now that we've talked about the clients and we're getting into the database server, now we're going to look at how they differ from MySQL to Postgres to actually run commands to do different. I have some very basic commands here in order to just show you an example of some of the differences here. And one of the things that I found really nice within PostgreSQL is the question mark, where you can actually list out the commands within Postgres. And so that's really useful because there may be some commands that you don't use all the time. And it's just like, okay, what was that command again? Okay, let me do a question mark and look at the commands. Oh, okay, here it is. Where MySQL, you have to go online, look up at the reference manual to try to find that command that you're looking for. So it's nice that PostgreSQL has wrapped that into their client. Now we're going to get into database and schemas. And with MySQL, as I mentioned before, they really don't have a concept of what a schema is. Now, if you come from an Oracle background, this is pretty self-explanatory. It's inherent in Oracle as well, where they have a separate, within a database, you can set up separate schemas, and it helps provide a logical separation between tables if you'd like that. By default, when you create a new database, it automatically creates a public schema for you. And there's also another default schema that's created called pgcatalog that helps keep some metadata of the tables that are created that you can run queries against to get different statistics and information about the tables. You can use it to, so like as an example, you can create one schema for a client, one client, and then a different schema for the different client and have the same tables in both schemas, because you can have the same table names between schemas within the same database. Now, for the MySQL users, this is pretty self-explanatory if you come from a MySQL background. Basic create user. Once you create that user, when you create the user, you provide where that user can come in from with the percent sign. Pretty much you could come in from anywhere. And with the newer versions of MySQL, they're starting to allow for roles to be created, which helps considerably with managing users, especially in larger scale organizations, where you can, let's say you have a development team. You have 20 developers, and you give them a base set of permissions. Currently in the 5.7 and earlier versions, if you wanted to modify those 20 users, you'd have to go through each user. And now, as they're starting to introduce roles, you can put on a particular role those permissions, and then add those 20 developers into that role. And then you could just change that one role, and then it will affect all 20 users. So that's been in since Maria 10.0, which is, they've incorporated it much earlier, and then Oracle's finally coming around in 8.0 and introducing those roles. Now for Postgres, that's nothing new. They're even going a step further in deprecating users. They only have roles, and with the newer versions. I think with 9.6, you could still run a create user, and even within the documentation, it says for create user, this is becoming deprecated, and you'll start using create role going forward. Now, to differentiate between a role being a user or a role being a group is whether you have the login permission. And once you give that role a login permission, it becomes a user. It can then log into the database server. And then the way that Postgres restricts where that user can come in from, they create this PGHBA config file on the database instantiation. And then you can restrict where the user can log in from, and even the database that it can log in to. So they're much more granular on their security, and this file is accessed every time a user logs in. So as soon as you make a modification to this config file, it is immediately used by any new connections that are coming in. And another thing about Postgres is they can even go down to the column level in restricting a user and their ability to query a table. So if you want to really restrict the application and say you can only access this column of data within this table, within this database, you can do that. So that's really good from a security perspective. Now this is one of the biggest shocks that I've seen, is how the two databases handle connections. With MySQL, normally if you want to check if MySQL is running, you can do a service status, or you look at the processes that are running on a server. And typically you'll see one process, MySQL. And then as connections come into that MySQL server, within that process, MySQL will spawn threads. And that's how MySQL manages connections that come into the database. Threads are very lightweight, and each thread is approximately 256K on a 64-bit system. It uses less CPU utilization because it's only spawning the new thread within an already running active process. But the downside of that is, if something happens to a particular thread and it crashes, the entire MySQL process dies. And one interesting thing is, within MySQL, to show the threads that are connected, you run show process list. It should actually be show thread list, because those are actually individual threads. For Postgres, it is completely different. The main Postgres process that's running is called the postmaster daemon. And that's spawned when you start Postgres. And then as a new connection comes into the database server, the postmaster process will spawn a separate process at the OS layer called a backend process. And those are much heavier in memory consumption. They can use upwards to 10 megabytes per connection. So when scaling Postgres to larger sizes and the applications that are going to be accessing that database, memory management and the number of connections that you have coming into that database is critical to not crashing that server. So definitely keep that in mind when scaling a Postgres server to a larger sizes. For MVCC, which is the concurrency control, so I mean, these databases are getting updated, new records being inserted regularly. And so the database has to try to keep a consistent state of data in order to respond to your queries that are coming in. And so undo logs stores the data that's changed within a transaction for it to be able to roll it back if it doesn't complete. And so when a record is deleted within the table, it actually doesn't delete it physically out of the table or logically until the commit happens. And then it will remove it out of the table. And so if you're deleting half of a table, after that commit happens, within the table space, that space is freed up in order for new data to be able to go in. So that's why it's pretty important within MySQL to commit your changes pretty regularly. Now with Postgres, it is a completely different ballgame. They approach it completely different. When you delete a record within a table or you update a record, when a record update actually inserts the new record with the new data and just marks the old data as deleted with the transaction ID. Or the deleted record is just marked with the transaction ID. There's actually a really good talk that happened yesterday, and they go through that in very intense detail, and it's actually covered in this blog post down here. But that unused data is still in your tables, and it's using space. And the only way to clean out those records, or as Postgres refers to rows, are tuples. And you want to get rid of those dead tuples on a pretty regular basis. And they have a process called vacuuming. And the vacuuming process is spawned by that postmaster process. And it goes through the tables and it cleans out those dead tuples. And it makes that space available for reuse. But it doesn't reclaim it on the disk. So MySQL is the same kind of concept. It just removes it out of the table space, but it doesn't reclaim the disk space. Within MySQL, you either have to optimize the table or you have to run a change engine in ODB, and it will rebuild the table and reclaim that disk space. So for Postgres, you have to do a vacuum full in order to reclaim that disk space. But similar to MySQL, in optimizing the table, it will lock that table and it will prevent transactions from completing. But Postgres offers, I don't know if this one is written by Postgres themselves or if it's a third-party tool, but there is a tool called PGRepack, which is an online full vacuum tool to being able to clean out those tables and reclaim that disk space. But I mean, you could even, for the blog, you could even do a Google search for understanding bloat vacuum Postgres, and it will be the first result. And definitely highly recommended if you want to understand the cleaning out of the vacuum process. For memory management, MySQL is your typical buffer pool. This image is starting to get a lot of, I've seen it in a bunch of slides, and even recently Peter Zaitsev put it up on LinkedIn, that it's a very popular image of showing the inner workings of MySQL. And the main thing that we're looking at is the buffer pool in the log buffer over there. And that is where the memory space is used within MySQL to store the buffers, the caches, the indexes, and even row data. And then the InnoDB log buffer is where it allows the transactions to run without having to write the logs to disk. For Postgres, for the memory management, you have, I'm reiterating the back-end processes here because of the importance around making sure that you keep that in mind for the connections that are coming into Postgres. So you definitely want to keep that, and to help manage the connections that are coming in, a really popular tool that's used a lot of the time is called PG Bouncer to help reduce the overall number of connections going into Postgres and creating a connection pooling. Then the main buffers are the shared memory configs within Postgres, and that is used by all the processes within Postgres. And typically you're going to want to size that to 25 to 40% of the system memory, whereas the InnoDB, you're going to want to size that to about 80% of the file system. So Postgres, I find, uses much more of the system OS level cache. So you want to allow more memory there, as well as for the connections that are coming into the database. You want to allow a little bit more space there for that. Now for replication, MySQL takes the changes that are made on the master and it puts those changes into a binary log. And it then can utilize those binary logs to replicate the changes over to slaves. And Galera clustering even has its own method of replicating the data to the Galera slaves. And you could set up replication in multiple different fashions, where you can have a traditional master-slave, you can have a master-master, where you can accept writes on both servers. You can even do a multi-master and even chain replication. So it's very versatile in what it can accomplish. And by default, when you set up replication with MySQL, it assumes that you want to replicate all changes that from your master to any of the replicas. And in order to change that behavior, you have to set up filters in order to say, okay, I only want to replicate this database to this server, or I don't want to replicate this database to this server. One that I typically see a lot is customers don't like to replicate their MySQL database. And so if they add new users, they have to actually go to each server in order to add the users, because the MySQL database is not being replicated. For Postgres, they actually have two methods of replication. The first method is streaming replication. This is their original method of replication that they came up with in order to get the data from this server to this server, and to start the process of being able to do a failover. So it's actually took them a while. I think it was introduced in 9.0. I actually thought it would have been implemented far sooner, more to the origination of the database, but this is the original method. It has its limitations, but it does pretty much what you need it to from a bare bones. I need this database replicated to another server in order to being able to fail over in the event my master dies. One of the downsides that I found is that when replication breaks, there's no fixing it. The only fixing it is rebuilding of that slave from the master. Whereas like MySQL, you get a bad record come through or something like that, you can skip an event, or you can potentially even change a record to kind of get it to start flowing through again. With Postgres, once that breaks, you're rebuilding that slave. From my perspective, from my experience, from what I found. There may be methods of doing it that are more expert level, but that's what I've come to find. And there are no filters with this type of replication. When you set it up and it's replicating, you can't decipher, okay, I only want to replicate a couple of the databases or some of the tables or something like that. You can't do that with the streaming replication. And one of the big drawbacks is the versioning. The master and the slaves have to be exactly the same version. You cannot differ on that. So it really impedes upgrades in being able to, where MySQL you can have 5.6 replicating to a 5.7, doing failovers to try to get those servers upgraded. But with streaming replication, that is not the case. Now, with version 10, they started getting the idea that we need better replication. We need to have more flexibility. We need to be able to do more with it. So Postgres implemented logical replication. And sorry, it's a lot of text to go through here, but there is a lot about logical replication that I want to really get across, that the capabilities of what it can do. And it has its own unique concept of what and how it's doing it. So for what MySQL would call a master, Postgres would call a publisher. And a publisher is pretty much presenting material for a subscriber, which MySQL would call a slave, to subscribe to and get that data. And when you initially configure a subscriber for a publisher, it will go out and say, okay, I'm going to subscribe to you. The publisher will back that data up, send it over to the subscriber, restore it, and then start the replication chain automatically. All of that's built into the whole process. So all you need to do is just say, okay, publisher, subscribe, that's it. It does the rest of the process for you. MySQL is still a little behind the times on that regard, where you have to back up the data, make sure the positioning, or if you're using GTIDs, it will have the positioning. You get the data restored yourself, and then you set up the replication between the two, where this does all of that for you, built in. And then where MySQL uses binary logs, Postgres uses wall logs. Same concept, and just records the changes that are being made, sends those logs over to the slave, and then it replays those logs and gets the data to be transferred over. And much more versatile than the original streaming replication, where it allows you to do similar things that MySQL could do, where you can have multiple masters. So you could have multiple publishers and one subscriber that can subscribe to them. So you could have database 1, database 2, database 3, and then one subscriber that they all replicate to. Vice versa, you can have one publisher and 3 subscribers. You set up one publication, you set up each subscriber to subscribe to it, and then that data gets transferred down, and then the replication gets started up. Now, there are some limitations where if in MySQL you run a truncate on a table on a master, it's going to truncate the data on the slave. In Postgres, that's not the case. Truncates are not going through replication. Neither are alter statements, DDLs. So if you want to make changes to your schema, you cannot do it through replication. You have to do it on the publisher. then you have to repeat the process on the subscribers. And another nice thing that they have about their replication is also you can go down to the table level for publication. So you could say, I only want to publish this one table. And the subscriber can say, okay, I want to subscribe to that publication. And only that one table will be backed up and then restored on the subscriber and then transferred down. So much more flexible, and this can also be used for version upgrades. So if you have Postgres 10 and then you're looking at going to 11, you can utilize logical replication in that upgrade. For the final topic we're going to talk about for the major differences is the file system level. So for MySQL, your data files are located in the data directory. Pretty self-explanatory. And then the logs that it generates are also in the data directory, but you can configure those in the configuration file to be in different locations. Then by default in 5.6, I believe, the file per table. So every table is going into its own files. Then the folder structure is similar to the layout of the database and tables within MySQL. And what I mean by that is if you create table 1, database 1 and database 2, when you look at the file system in the data directory, you're going to see directories the same names as the databases. And then as you create your tables within those databases, you go into those directories, you'll see the files that match the names of the tables. And for partitioning, you create partitioning on a table, it will split those files into individual files on the file system level. Now for Postgres, it has some similarities, but there are also some differences. The similarity that we have here is the data directory houses all of the data for the database. But where we start to differ is when you go into that data directory, they don't name the directories the same name as databases. And to try to find the database and the tables that you're looking for on the file system, you actually have to run commands in the database to try to determine where they're located. And so here's a couple examples. You can do a show data directory command within Postgres, and it will show you where your primary data directory is. Then you can run a PG relation file path and then put in the table name. And this is assuming that you've already connected into a database. And then it will give you the path of where that table is located on disk within that data directory. And for Postgres, by default, it will split files based upon the default size is 1 gig. So if you have a 5 gig table, it will be split across 5 files by default. And that's with no partitioning. Where MySQL, you could have one table a terabyte in size, and you'll have one file a terabyte in size, where that's not the case with Postgres. And you can change that 1 gig limit, but I think you have to build Postgres from source code in order to change that. And then some of the minor differences, these are some of the smaller ones but that I've noticed, but by no means is it an all-inclusive list. Postgres has a true Boolean type where it's true or false, where MySQL, if you want to try to get the same type of functionality, you have to create like a tiny int and set it to 0 or 1. This one was kind of surprising to me is within Postgres, when you create a table and you want a primary key to auto increment, they don't have auto increment. They have what's called serial. So you would do a create table with the column and you'd put serial where you would normally put auto increment from a MySQL perspective. MySQL is not case sensitive. So if you had test one with a capital T and test one with a lowercase t, those are the same in MySQL. In Postgres, that is not the case. Postgres is case sensitive. So if you come from a traditional Linux, you know exactly what I'm talking about. And Postgres is truly open source. No one owns it except for the open source community. And so all the products that they offer are completely free. Where Oracle owns the MySQL source code. And they make modifications to it, and then the other database companies kind of piggyback off the main core changes that Oracle makes. But they ultimately control that source code. You can try to contribute to it still, but they ultimately own it. And they own the updates to it. Minor difference is MySQL is a relational database, where Postgres is an object relational database, sorry. And what it allows Postgres to have better control around customizability and extensibility. And that is one of the biggest advantages that Postgres provides. It provides a developer's dream. It allows different language types to be written within their procedural languages. You can use the traditional SQL. You can use Perl, Python. So if you're a developer that knows a particular language or multiple languages, Postgres is very intriguing for you. They have data domain objects for constraints across tables. So if you wanted to say, I want to create an email field, and I want to ensure that it has that particular format, you can do that at the database level with these. MySQL doesn't have anything. You create your field and you put the data in it, and you can't really have something built into the database that can look at that and make sure that it constrains to a particular type. Postgres has table inheritance. Table inheritance is, the best way I can describe it really easily is if you're joining multiple tables to try to find similar data, Postgres can do this inherently in a single query without joins. And you just specify the tables that in the data that you're looking for, and it will inherit the data across the tables. So it's something that Postgres allows you to do that MySQL cannot. Materialized views. So you can create views based upon queries that can be updated regularly just by updating the view. And it's used typically in data warehousing for large data sets and being able to take data from multiple places and create a nice view for you. But once again, it's highly extensible to the point you can create your own data types. And that is pretty impressive. Index types, functional languages. You can even override different parts of the system, where MySQL, you cannot do that. A lot of times I see Postgres are part of applications that are prepackaged with their databases. A lot of the times that's the case because of this type of customizability. They can customize the database to work the way that their application works and make it work more efficiently. So that is one of the specific features that Postgres provides. And these are all the different locations where I got a lot of the different information. I know the slides are uploaded and then they're also available, so you could take a picture and all, but you can also get the slides later on if you'd like, and you can get all the links and everything from the slides that are provided after the conference is over. Thank you very much. Any questions? Yes.
Hi, Kevin. How are you?
Good. How are you, Peter?
Hanging on, doing all right. So you noted something about data files in Postgres being limited to 1 gig and then it cycles to the next file. Is there
Correct.
any kind of key overlap between those files? Does it actually make sure that there's no overlap between the files?
I do not know.
Okay, fair.
Any other questions?
I had a question about replication.
Sure.
So I guess the logical base
Yes.
replication, what type of crash recovery is available? I mean, you said your own parameters, for example, if a subscriber goes down?
Yes. Yes.
I guess depending on how long the length of time is down, how does it connect back and recover the data that's accumulated on the publisher?
I believe it rebuilds, it goes back out to the subscriber and re-downloads the data and initiates the replication again.
Okay, so there's no manual intervention, I guess. You
Correct.
start up the instance.
Yes.
Like I say, if it's down for a long amount of time, then you might need to rebuild.
I would have to look into that one.
There's a thing called replication slots that tracks what that replica was. So
Okay.
as long as there's enough space on the publisher to maintain all the wall logs,
Yep.
right, that it needs, it'll pull it to. If it's down for a couple weeks, you'll just run out of space.
Right.
Yeah. Yeah, similar to the MySQL replication where it's all in the binary logs, and then it will just, once you start that slave back up, it will be like so many seconds behind. There's a command within Postgres that you can check to see the status of replication and make sure it's caught up.
Okay.
I have a question.
Sure.
On the MySQL, you have a thing called MySQL build log to see the logs, right? To see
Mhm.
what is inside the log. Is there anything on the Postgres that you can?
Yes, there is. I don't have it in front of me, but there is a command that you can see the wall logs
Okay.
that are available.
And then how hard it is to do an upgrade from 9.2 to 11? Like, is there any specific?
That one, to do such a major upgrade from like 9.2 to 11, I would actually do that incrementally to the major versions, just to make sure that it's incorporating the differences. There is no doing it online. I'll tell you that straight up. You will have downtime.
Well, there's so many significant changes just between, I mean, getting 9.2, 9.6, making sure you've got a really nice, stable.
Exactly.
That your environment's stable.
Yep.
Before you try to roll it to 10. Because keep in mind, logical replication is something that's bolted on before. Now it's built in, fully baked.
Exactly.
So, I totally, what you said about incremental is really the best approach.
Yeah, and we even approach that Pythian when we're doing like MySQL upgrades. We even take the same approach where we'll set up even replication chains from one version to the next. MySQL is nice; it allows you to be able to do that. We've upgraded, I think, from like 9.1 to 9.6 before. 5.
We've gone from 5.0 to 5.7 before.
Yeah, and just setting up replication between them. And they could point their application to the different slaves within the replication chain to test them out and make sure that it's working the way we want.
Can I also add a recommendation to that, though? I think often it's even more important that you're in the most recent minor release than it really is about you being at that higher level.
Yep.
Because if you think about August of 2018, there were a whole lot of, there's a big, what do we call it, quarterly update.
Mhm.
That there were bugs and security issues that were fixed last August. Those minor versions aren't just a thought exercise. It's meant to keep your database secure,
Definitely.
performing, robust, and all that. So
Definitely.
I would add on.
The one thing about the minor updates that's really nice is being able to do those with minimal downtime. And they're less impactful to the actual overall running of the database. And you could do those a lot more safer without potentially impacting the way the application interacts with the database. Yes?
Does Postgres have a way to promote a subscriber if the primary goes
That would be a manual process so if you're using like PG Bouncer to manage your connections, you would redirect that to the new master.
Okay, so where I'm going is like, I'm assuming logical replication is asynchronous, right?
Correct.
Do they have like a concept of semi-synchronous or synchronous replication where you can guarantee at least one subscriber has the data?
I believe so. I don't want to say for sure, but I believe so.
Logical replication can be synchronous if you set it that way.
Yes.
I
Yeah.
wouldn't recommend doing that.
Yes.
This is kind of a higher level thing, because I'm a Postgres community. How would you help a MySQL developer or DBA move into Postgres? I mean, I find out I talk to MySQL folks who are intimidated by Postgres. What would be kind of that? How would you kind of help ease someone's mind at?
This is the first step.
Yeah.
And
You've got some great details and features, but like, how do you just like?
well,
It's okay. You're gonna make it.
the key is having someone with experience being able to answer those questions. And this is one of the key first steps that we're taking Pythian as internally to start getting the MySQL guys more into understanding Postgres and what it's capable of doing, and just identifying the differences, because they have a lot of MySQL knowledge, but it's a matter of first showing them what the differences are and then just building from there. And as they have questions, being able to answer those and building them up. So we're definitely taking that approach within Pythian, because we do see the growth that Postgres is starting to have, especially with a lot of companies wanting to get off of Oracle and reducing that licensing costs. Peter Zaitsev even had it in his keynote earlier today, where a lot of companies are moving to open source to reduce that cost. And Postgres is one of the major database platforms that Oracle people are moving to, as well as with MariaDB, where they're incorporating some tools to being able to migrate into their database platform as well.